If we move away from the simple measurement of PM through size, and we start caring about what it's actually made of, how practical is it as of today to work out what it is? Practically today, is it possible to measure what these things are made of, and how hard a process is that to be able to scoop up a volume of air and then actually be able to tell what's in it?
It's very, very feasible, but it's very expensive. So we have, in London, we've got the London Air Quality Network, over 120 monitors across the 33 boroughs. So fantastic network, tells us how much we're breathing from a mass point of view or from a number point of view. But if we want to know what we're breathing, then we've got 2 stations in London. We call them super sites. One of them is on Marylebone Road, a very busy road in central London, and the other is out at Aereco Park on the playing fields beside a school. No real traffic sources near it. So it's a background site and a roadside site.
So in London, but not directly next to a source, and then in London, right next to the source.
Right next to the source, which we have worried about for decades, traffic.
Yeah.
Now, in Marylebone Road, we've got about £2 million worth of equipment. But that equipment tells us, as that bus goes past, that it's a diesel bus. It tells us what type of diesel it's been filled with that morning, and that's from the signatures of all the metals and components of the particles that we were talking about earlier, that mixture on the surface of the particle. And it'll tell us whether that bus has braked within the vicinity of the site, because again we'll get signatures coming from the brake discs, and it'll tell us what type of tires it's on the vehicle, because all these tires from different manufacturers, they've all got their own specific chemical signature. So it is possible, but it's expensive.
Is it necessary? I imagine there's huge value from a research perspective of speciating, understanding those chemical signatures of everything that's going on around you. Is that something that should be happening more widely, or are the 150 stations giving you enough information to tell you what you need? Because sometimes in life, we can overcomplicate stuff. At the end of the day, if there's a lot of particles in the air and they're peaking during rush hour, we can make a pretty good guess at what those particles are going to be made of. Likewise, if we've got a particle counter in a kitchen and it spikes during dinner time, there's a good chance we know what the source is. So at one end of the scale, sometimes the solutions don't need the really precise measurement. We need to figure out how to stop that happening or protect ourselves from that risk, don't we?
So there are 2 stories here.
Yeah.
The first story is we need the really intense monitoring to tell us what the sources are and what the components are in those sources, because that then allows us to decide whether that source or sources are problematic from a health viewpoint. So what we've done in the past is we've compared the particles at Marylebone Road, understood their chemical signatures on a mass basis with particles at Aereco Park. And we were able to definitively show that these particles coming directly from fresh traffic are much more toxic than the particles over here. So that, once you have that information, then that allows you to say, we need to do something about traffic and the sources of particles from fresh traffic if we're going to reduce the health impacts. On the other side of the story, we do need monitoring on a wider scale at a less sophisticated manner, because on the days that there is higher pollution because of the weather conditions or because the Netherlands are spraying all their fields with fertilizer and it's come over. We need to be able to tell people, look, the pollution is worse today. If you're an asthmatic, make sure you've got your inhaler with you. Kids, maybe, don't let them go and run around the playground today, do something inside instead. So it's two different stories.
Yeah. And I guess it's also really powerful for evidencing the efficacy of things like low emission zones. You're able to show over time the change in the composition of the air. And that's what happened in London, didn't it? That you were able to demonstrate through research the risk and associate that with the epidemiological outcomes that were happening. And you've been able to show the impact that has at a chemical level, at a particular level, following the ULEZ. And I think the last time I spoke to you is you were saying we're now starting to see the epidemiological outcomes, which are the downstream effects that, we're able to say, here's a problem, here's the evidence to show how harmful it is, here's an action, here's the results, like this, we can demonstrate that we're seeing a reduction in pollution, and now you're seeing the downstream impacts of the epidemiological benefit.
Absolutely. So the most powerful piece of work I think we have undertaken in our sort of journey is we were able to show that children living in East London who were being exposed to a lot of traffic pollution, heavy traffic pollution, just simply from where they lived, how they went to school, at their school playground, they were being exposed to a lot more pollution than children living outside London. And whenever we followed their growth, and particularly their lung function, we were able to show that that was slower than the children who weren't being exposed to the traffic pollution, even though they were living, similar sorts of lives, eating similar sorts of diets, etc., just normal kids. And when we published that data and took that to the GLA, that was really the piece of work I think that made them push forward with the ULEZ, because it was very clear that just simply living in London was having this restrictive effect on children's lung development. And there's very good data in other situations that if you have a poor start to life and don't attain your full lung growth, which by the way stops, around the sort of the teenager days, you live with that lung the rest of your life. And if you've got a smaller lung than you should have, then you're much more susceptible to other problems later in life. So it was a really strong piece of evidence which allowed the policymakers to make some difficult decisions about curbing traffic.
And for international listeners, the GLA is the Greater London Authority. So that's the authority that looks like it's the mayor basically.
Yes.
And the organisation looks after Greater London.
Yes.
London as a whole. And the ULEZ is the ultra low emission zone. So this is effectively an area in central London where there's significant limitation on combustion vehicles.
Well, it's even extended beyond that now. It started in central London in that congestion zone area, and then it was expanded out to what we call the North and South Circular, which is about half of London, I would say. And then at the end of 2023, it went out to all of London within the M25. And it really has accelerated the modernisation of the fleet, the vehicle fleet in London, and of course, more modern vehicles are cleaner, at least if they have a combustion engine, they've got better filtration of the particulates.
Yeah, and I think as a fairly infrequent visitor to London, you can actually tell. There's been an actual physical difference.
Yeah.
I think there's no doubt about it. As a kid that's been coming into London since his teenage years, there's used to come back home with black soot, black bogies,
blow your nose.
Black bogies.
Yeah.
As a result of coming into London, it was just the thing. No, that's really powerful. Did that expansion of the ULEZ zone happened over a period of time? Did during that period of time when you were monitoring that process, because I know you were heavily involved in that, did you see the problem being shifted out? Like, so when the ULEZ zone initially happened in central London, did that just shift the problem out or exacerbate the problem out? Because that was always the trope, I think, that was kind of put out there, was that you're just moving a problem from one area to another, right? Did you see that in the data at all, that you saw an increase in pollution on the peripheries of the low emission zones?
No, definitely not. It started in that central area because that had the highest pollution, and it also had the highest bus and taxi use, and the GLA obviously have more control over those fleets, so they were able to modernize those at the same time as telling people you have to have this type of vehicle if you're going to come into that central area. So because it had the highest pollution, they started there, and they were able to demonstrate benefit, within, I think it was the first year's report showed substantial drops in nitrogen dioxide concentrations. That gave them the confidence then to move out to the north and south circular areas. But we didn't then see, the pollution moving further out. That pollution was always there, and it didn't get worse as a consequence. But it did get better where the ULEZ was introduced.
That's really interesting, isn't it? Because that's the kind of I think the logical assumption is that you're effectively just everybody's now just orbiting the low emission zone, and that now in cars some way you're just kind of moving like a ring around Venus, out and out and out, but that's not actually what's happening. You're just effectively just removing pollution sources where you introduce a low emission zone.
People kept to their normal routines, and if they had to come in, then they either took public transport or they had a vehicle which was compatible.
Yeah. And, you see that in the data. I remember hearing a presentation last year, and they were saying that in central London now, the primary source of particulate matter is commercial kitchens. Yeah. So there's a new problem to think about, perhaps, but and we'll come on to that actually, because we want to talk about the battle in the lungs. But it just goes to show that this is impactful, that effectively it's been able to reduce particulate matter from traffic sources now to below one of the problems that was below it. Yeah. So it works. And
it was also, the fact that the traffic pollution, that fresh diesel emission, was the most problematic from a toxicity point of view. Yeah. So not only did we reduce the pollution, we reduced one of the more toxic forms of pollution.
Yeah.